Hey guys, it's Maya with Peer Tutoring Chemistry. Today we're going to be reviewing balancing nuclear equations. A balanced nuclear equation is one where the sum of the mass numbers, the top number in the notation, and the sum of the atomic number, bottom number in the notation, are equal to each other on either side of the equation. So here we have helium 4 over 2. Just as a review, we can see that the top number in helium is the mass number. So this number right here, this 4, tells us the mass number, and then the bottom number right here is the atomic number. The mass number is the sum of the protons and neutrons, so we know that the sum of the protons and neutrons of helium is 4. And then the atomic number corresponds to that number found on the periodic table, as well as the number of protons in the elements. When we solve nuclear equation problems, they will often be presented such that one particle is missing and we have to solve for the identity of that particle. Now, before we can start solving nuclear equations, let's go over the different particles that you need to know. Many nuclei are radioactive, that is, they decompose by emitting particles and in doing so become a different nucleus. All of these elements can go through nuclear changes and turn into different elements. In natural radioactive decay, 4 common emissions occur. There are alpha particles, beta particles, positrons, and gamma rays. Alpha particles can be written in two ways, either helium 4 over 2, we saw earlier, can be written as an alpha particle like that with 4 over 2. Beta particles are essentially fast-moving electrons, and they're written as a beta symbol with 0 over -1. They can also be written as an E with a 0 over -1. And again, just from reviewing from before, we know that the beta's mass is around 0 and its atomic number is -1, so it gives off a -1 mass, atomic number. Positrons have the same mass as an electron but have a positive charge instead. They're written as beta 0 over +1. They can also be written as E 0 over +1. Yes. Gamma rays are photons of very high energy electromagnetic radiation, but they have no mass or charge. They're written as gamma, and usually they're given like a 0 over 0, sometimes they're not. Now that we've gone over the different particle types, we can begin solving problems. Our first problem says, write the nuclear equation for the alpha decay of polonium-216. So there's different types of equations that we can go over, and one thing we have to be wary of is when it says decay or capture, and those are very common phrases that can be used. When we mention decay in a problem, we know that the particle is being given off in the products. On the other hand, capture means that the particle is being added to the reactants. So we know that alpha decay means that the alpha particle is being given off in the products. So let's just start writing off what we know. We know it's going to be a reaction, so we have this arrow. And we know that an alpha particle is given off in the products. So we have 4 over 2 helium. And it says that polonium is given off by alpha decay. So we know that polonium is going to be in the reactants. So now here at the top, it's going to be 216 because when we have something like polonium 216, helium 4, this number right here just tells you the mass number. So mass number we know goes at the top. Now to get the bottom number, the atomic number, we just have to look at the periodic table. If you look at the periodic table, we find that the atomic number of polonium is 84. That goes here at the bottom. It'll help make our math a lot easier. Now we're ready to solve this problem. If we look at either side of the reaction, we see that the numbers at the top and the bottom, the mass number and the atomic number, are not the same. They do not equal each other. Here we have 216, 84 on this side. Here we only have 4 and 2. So we definitely need something on the product side. So to solve this, all we have to do is just simple math. So we know here that 4 plus something has to equal 216. So just from simple math, we know it would be 212 because 216 minus 4 is equal to 212. So now the mass number of our mystery element is 212. The atomic number of our mystery element is going to be 84 minus 2, going to be 82. And to get that element, all we have to do is just based off of this 82 because that's the atomic number. That relates us back to the periodic table. If you look at the periodic table, That's going to be lead. So you know our answer is going to be lead 212. To check it, we can add both sides and see if they end up being equal to each other. So 212 plus 4, 216, 82 plus 2, 84. Perfect. Now let's look at the next problem. This one involves a particle capture. The problem says potassium-40 undergoes electron or beta capture. What is the result? So first, we know that because it's beta captured, something is getting captured, it's going to be added to the reactant side. So now we have a beta particle. A beta particle is 0 for its mass number and -1 for its atomic number. So 0, -1. And it's asking about the result, so don't know what's going here. And we know on this side, potassium-40 is going to undergo beta capture. So potassium-40 is going to also be added onto the reactant side because it's going to capture a beta and then there's a result that we don't know. So to do potassium-40, look at the periodic table. Potassium is going to be K. Top number is 40 because again, when we say element and a number, that number, potassium-40, 40 is going to be our mass number, and the atomic number we can again just get from the periodic table. So for potassium, atomic number is 19. Now again, it's just going to be simple math, so we know that the entire sum of the mass numbers is 40, so here our result has to have a mass number of 40. And then we know that the atomic number has to be 19 plus a -1, or 19 minus 1, which is 18. Looking at our periodic table, we know to check what the element is, you have to look at this 18 right here, because that 18 is our atomic number, and we can find that on the periodic table. And when we look at the periodic table, we see that that corresponds to argon, Ar. And that's our answer. Hope you guys had a great time and good luck on all your studies.